Once again, I'm Joe Ikley, the Extension Weed Specialist here on campus in Fargo for NDSU. And as Greg mentioned, so I'll be honest, this talk looked a little bit differently this time yesterday until we knew we would have a press release coming out in the afternoon. And so I had to kind of hastily pull some things together that we'll discuss at the end. So first, just wanted to give kind of an outline here of the things I want to talk about. So I was basically planning to share just a bunch of Waterhemp and Palmer amaranth data, some new research summarized over the last couple of years, and then this press release came out yesterday. So for those of you who are on that email listserv or may have seen it, I wanted to save at least 5 minutes towards the end to discuss some new findings in Kochia that are really gonna change some things for some folks as far as weed control is concerned. So first, I always like to talk a little bit about biology. So since most of this talk was originally shaped around Waterhemp and Palmer amaranth, I think I decided this winter I'm kind of done talking about the large plants that produce 1 million seed per plant and want to kind of give a shock and awe value the other direction. So we may often see these plants maybe post-harvest, late summer, 2 to 3 inch tall pigweeds. So we of course see the other weeds of similar stature, but since Waterhemp and Palmer are both known as prolific seed producers, I did want to show this plant that I picked out of the ground September of 2020, I believe it was. And this little 3-inch Waterhemp had 88 seed that I was able to thresh out of it. And so that's just what we're looking at on the right here, various levels of maturity of that seed. But again, just showing it's, we can show the big showy plants, but as far as seed production, we also need to consider these small plants, especially when we think about post-harvest considerations in wheat and other early harvested crops, or specifically the ones on my mind. And so I just wanted to show this video. This was during harvest of last year, just another way to visualize the seed production of Waterhemp. And so I clipped off about the top foot of a Waterhemp plant as we were harvesting soybean trials. And what I'm showing here in the paper bag is a 2-inch segment of one of those seed heads, and this is a female Waterhemp plant. And just showing how much viable seed is there on the plants that we're going to send through the combine and redistribute out the back end, and of course put some in the grain tank too, but showing there's a lot of 2-inch segments on that particular Waterhemp plant. So again, I just really want to focus on the seed production and showing a few different ways to think about seed production, because ultimately for our problematic weeds like Waterhemp, Palmer, and then Kochia, 0 seed production is our ultimate goal at the end of the year. So Waterhemp and Palmer data, I wanted to show basically 3 different trials, and I was just going to focus on pre-emergence herbicides, since this is, I guess, called getting it right. For me, getting it right in soybean production for weed control does start with the foundational pre-emergence program, especially with these problematic pigweed species. So the first trial that I wanted to show, this was conducted in Fargo 2 years in a row on Waterhemp, a Waterhemp population that we work with annually. And we've looked at different pre-emergence herbicides with and without a 1/2 pound of Dicamba, so the standard rate that we use in an Extend soybean system. I do want to point out that both these years we did have limited rainfall after we applied these pre-emergence herbicides. So this is important when we talk about the effectiveness of Dicamba as a residual product. We tend to see it be more effective in dry years. That's basically because it's one of our most water-soluble herbicides. So in a wet year, we tend to have it solubilize and leave the soil germination or weed seed germination zone rather quickly, but in dry years, we can get benefit. So I want to show here, this is just straight into some results. So this is combined over 2 years, what the data looks like 28 days after planting. So going down on the left side here, we have 5 different pre-emergence products or programs. So we have Warrant at 48 fluid ounces, Warrant plus Molar. Molar is a liquid Metribuzin, so 1/2 pint of that. Valor EZ at 2 ounces, Fierce EZ at 6 ounces, and then Authority MTZ at 10 ounces of that dry product. Those same products are then repeated below with a 1/2 pound of Dicamba, in this case, that 22 fluid ounces of Extendamax. And so we've got our results here going to the right. On the far right here, we have the numbers. So the numbers that represent that weed control, and the letters represent statistically what we're looking at for the stats. So a different letter represents significantly different results. And so the A is the best results here in this case. And so when we had a pre-emergence herbicide with that half pound of dicamba, for 28 days after planting, basically 97 to 99% control combined over 2 years. And then when we did not have dicamba, we did lose Waterhemp Control over this 2-year research window. And so depending on the product, anywhere from 77 to 88% control, again, less than when we had the same products with that half pound of dicamba. And this is just taking it out to 42 days after, so 6 weeks after planting, essentially. And by now, we would have liked to have a post-emergence herbicide on to clean up any escapes, but just teasing out the system and showing we still had greater than 90% control with all those premixes where we also included the half pound of dicamba. So again, in a 2 back-to-back dry years following herbicide application, definitely did see a benefit as far as 6 weeks out by adding that half pound of dicamba. Do not have it on the slide, but we did have a half pound of dicamba alone in 2022, and that would have been somewhere around the 70, I believe it was 60 to 70% control was where that would have fallen out in 2022. Again, that dicamba by itself. So we can't rely on that by itself for residual, but add it with the pre-emergence herbicide, and we get a pretty good, robust start for Waterhemp Control. Okay, next trial that I wanted to show. So this is a multi-state trial. I think there's 16 or 17 different states represented. This is just the data from North Dakota from this year. We'll have some combined data to present probably next winter. But the concept here is really taking a revisit or another look at Metribuzin for residual weed control. And again, our focus is Waterhemp and Palmer amaranth here. So the concept behind this is if we look at some of our premixes on the market that have Metribuzin, it's usually a full rate of another herbicide, either group 15 or group 14 herbicide, and then kind of a lower rate of Metribuzin to supplement that herbicide for more robust weed control. And so we kind of wonder if we flip that, use a full rate of Metribuzin, and then, what does that give us for the weed control? So the study I'm going to show, we had a rate titration 1 ounce at a time from 4 up to 16 ounces dry product of Metribuzin. And definitely what's worth noting, so don't know the exact rating on the soybean variety that we used. It's probably tolerant to Metribuzin though, because even at a pound of dry product, we'd never observed soybean injury in these trials I'm getting ready to show. And we did have some other herbicides for comparison. So again, gonna hop right into some results, and what we're looking at here is Waterhemp Control 4 weeks after planting. On the bottom, ignore that. That's the legend there is wrong. This is just pre-emergence Waterhemp Control. So on the bottom here, we have 1 pound of dicamba is what we used as one check, and then from left to right, 4 ounces all the way up to 16 ounces dry product of Metribuzin. Then we had 12 fluid ounces of Spartan. So basically the full rate for our soil type, and then 2 pints of dual magnum. So again, the full rate for the soil type that we were working with there. So what I want to show, again, 4 weeks after planting, in this case, 1 pound of dicamba by itself in 2022 was actually our best residual product. So our current label in the Extend soybean system, we can't use that full pound anymore, but we may revisit if we can use that full pound pre-emergence for a residual perspective for weed control. But just showing that was the best treatment that we had this year. And then, so again, same statistic setup. So all the A's are similar. And basically, once we got up to 8 ounces or a half pound of Metribuzin is when we started getting similar weed control. But we were pretty consistent overall once we got up to this 12 to 16 ounces of Metribuzin rate, pretty close to 100% weed control. And then anything less than half a pound is where we saw a definite drop off of residual weed control of water hemp. So again, just showing if we just look at Metribuzin by itself and we use these higher rates, we can get pretty good residual control on the pigweed species, in this case, water hemp. Same exact data set or treatment list, but this time for Palmer amaranth at a site we had in the eastern part of the state. And so overall, less weed control on Palmer amaranth. We had a bit more rainfall at this site and a little bit heavier population compared to what we were working with at our water hemp site. But here, that 1 pound Dicamba was still one of the best treatments. So 90% control of Palmer amaranth 4 weeks after planting. And then still, once we get up to, well, statistically, once we get up to about that ½ pound rate, we didn't see too many differences, but we had some variability at this site. But the really consistent control was basically over 12 ounces of Metribuzin is where we were starting to see 80 to 90% control more consistently. And then that 12-ounce rate of Spartan was one of the better treatments too. And so again, important in context, we were working with a Metribuzin tolerant soybean variety. In this case, we did not see injury. And so we are going to repeat this next year. And we're probably going to put this on a sensitive soybean variety too, just to see what rates we could maybe get away with on some more sensitive varieties and still get some of that weed control benefit. Okay, last research I wanted to show before moving on to the Kochia news. And so this is just 2 years of 15 different pre-emergence products on our Palmer amaranth research site. So this is the eastern part of our state, one of these populations that we imported with resistance to 5 different modes of action. And just wanted to look at which soybean pre-emergence herbicides work best for us on this population. And so here's just a chart of the different products. And really, I put this on the screen because I did want to show we used the full labeled rate that we could on this soil type. So maybe higher rates than most people are typically comfortable with or want to use, but really seeing if we go that full labeled rate on some of these products, what we're getting weed control wise. I should note we did include Prowl H2O. We cannot use Prowl pre-emergence in soybeans in our state, but it is something we could use in something like sunflowers pre-emergence. So just wanted to include that for some data points as well. And again, we're going to go straight into results here. And so what I've also added on this slide, so from left to right, we have all the products at the bottom there. These numbers at the base of the bars is these herbicide site of action. So we've got our group 15 herbicides grouped over here on the left. Then our group 14 herbicides. Group 5 is Metribuzin. Group 3 is that Prowl treatment. And then on the right is where we have different premixes that have various combinations of groups 14, 15, and 5. And again, at the top is where we have our weed control 4 weeks after planting. This is 2 years of combined data. And what I'll just point out is that in general, on the right side here, where we have these premixes with multiple modes of action, is where we have our most consistent weed control, generally 87% or higher. On the left side, where we have single active ingredients, again at full rate, we're still getting 75 to 85, up to 89% control with that higher rate of Spartan. And so again, some decent residual control, but that means we still have quite a few plants to apply a post-emergence product to. A couple interesting things I wanted to point out with this particular population. So this population is resistant to atrazine, which is the same site of action as Metribuzin, a group 5 product, but it is non-target site resistance, which means it can basically metabolize atrazine, but Metribuzin is still effective. And this is pretty consistent with reports on some non-target site atrazine-resistant Palmer amaranth across the U.S. So showing in soybeans, we still get some decent activity out of Metribuzin. Prowl, in this case, pre-emergence. With the group 3 herbicides, there's usually some resistance or tolerance in Palmer amaranth, and we will be exploring potential resistance in this population to the group 3 herbicides this winter. a little bit more difficult to tease out resistance from a pre-emergence standpoint than post-emergence. But that may be one potential reason why we saw a pretty low control out of prowl by itself on this Palmer amaranth population. Okay, so that was the new research I wanted to get through. And now I want to have the remainder of my 5 or 7 minutes here to talk about this press release from yesterday. So for those who are on the email list, you would have seen this article put together by Brian Jenks, our weed scientist based out of Minot. So he recently got through some greenhouse testing on a few different kochia populations. And thanks to Brian for providing these pictures. But what I basically want to show is he tested AIM and Sharpen on 4 different kochia populations that have had that weren't controlled this year and maybe last year as well with either AIM or Sharpen. So the top left of the screen is what we're looking at in an individual picture. So this is AIM at 1 and 2 ounces with the appropriate adjuvants. Kochia was sprayed at 2 to 2.5 inch tall kochia, and this picture is 8 days after that treatment. So on the far left here, we have a susceptible kochia check that Brian has in the freezer that we're able to pull out and use to look at just as a susceptible comparison to herbicides. And then populations from 4 different areas across the state that have reported issues with AIM last year. So 1 ounce is in the front, and the 2 ounce rate is in the back. And again, showing these susceptible checks on the left are all pretty dead, maybe a little green there, but basically dead. And then have some symptomology, like in this mott population, but overall minimal symptomology and quite a lot of growth. Same populations, same lineup, but this is 13 days after treatment. So again, susceptible check here is dead as a doornail. And then the different populations from 4 different areas of our state, a lot of regrowth, doesn't even look like we sprayed anything. So that's AIM. Same populations, but looking at Sharpen this time at 1 and 2 ounces. And so again, same setup, 1 ounce of Sharpen is here in the front part of the picture. 2 ounces of Sharpen is in the back. This is 8 days after those kochia plants were sprayed at 2 to 2.5 inches tall. And in general, a little bit more activity out of Sharpen, but still a lot of green tissue, a lot of regrowth 8 days after application at the 1x rate. And then even at this 2x rate, particularly this Minot population has quite a bit of regrowth there. And again, same setup, but now 13 days after that Sharpen application. Susceptible check, all the plants are dead. Might have a few dead plants scattered throughout, particularly the mott population. But we do have a range with our 4 different populations of maybe some susceptible plants still there in the mott population, Minot, and maybe even Berthold to an effect. Basically, all the plants survived minimal symptomology and had quite a bit of regrowth. So, what do we know and what don't we know about what I just described there? So, what I didn't mention, as far as what we know, is that we also talked with one of our colleagues up in Canada, and he has one population from Saskatchewan that's surviving a 16x rate of Sharpen. So basically, a pint per acre of Sharpen, this kochia population that he is working with would survive that. So we know we have several populations, basically the central to western part of the state. Adding in Saskatchewan, we know it's as widespread as basically Saskatchewan down to Mott, at least. So a pretty wide geographic footprint that we're finding what we will kind of officially confirm as resistant later this winter, but it's certainly for us surviving this 1 and 2x rate in the greenhouse. We also know glyphosate resistance in kochia is pretty prevalent in these same areas. So that's going to make burn down applications more difficult if we can't rely on glyphosate, and we also now can't rely on AIM or Sharpen on some of these populations. And we just know this is unfortunate. What we don't know, some of these things we'll be trying to figure out this winter. We'll be conducting a lot of greenhouse research to try and get some answers as soon as possible. Sensitivity to other group 14 herbicides. So for group 14 resistant pigweeds. We know the post-emergence products like Cobra and Blazer don't work. We can get some residual control out of sulfentrazone, which is Spartan. Flumioxazin is Valor products. On the pigweeds, we know we have reduced control, but still some control out of these products. We don't know if Kochia is going to act the same way. And then some of these more academic type questions is the resistance mechanism. Is it target site or non-target site? We know we have a pretty widespread geography to start with, but exactly how widespread are these populations? And then we'll also be trying to test the effectiveness of other herbicide programs to control these populations. So I see Greg's up, so I probably have about 30 seconds left. So I'm going to stop with this slide here. Just thinking about the remaining burn down options on these populations. If we assume AIM and Sharpen won't work, and if we also can't rely on glyphosate due to glyphosate resistance. So we're going to have a lot of reliance potentially on gramoxone or paraquat. Ahead of soybeans, we can tank mix that with Metribuzin, and that is preferred. There is a synergy when you tank mix paraquat with Metribuzin on emerged plants, and we'd also get some residual control from the Metribuzin as well. So that's probably going to be one of the better programs we can use, burn down. We can still use Dicamba on these populations, or I guess we will further test that this winter, but we do know we have some Dicamba resistance in some areas across the state too. So worst case is we would have group 14 Dicamba and glyphosate resistance. We don't know if we're there. We'll be evaluating that this year. Glufosinate or Liberty we can use as a burn down, but that's pretty risky in our eyes of just based on weather conditions we need for optimal glufosinate activity. And then we could have to till some of these fields. So a lot of these are no-till fields, and we don't want to till them up. But for Kochia control, that it still will remain an option and may have to be one option for consideration in some of these fields. So with that, I'm going to stop there.